All right, here's another type of problem where this time we're looking for the radius. So we can't just easily calculate the circumference right away. But we can start to think about what we know. We know arc length is always going to equal to some fraction of the circle times the actual circumference of the circle. And we say, what do we know in this particular situation? We know the arc length is 20 over 9 times pi. And do we know the fraction of the circle? Well, this is 80 degrees, so we know the fraction of the circle they're talking about is 80 over 360. And then from there, we could calculate the circumference. So if we go through here, we say, okay, what can we do? Again, a little bit easier with a calculator, but without it, we can still do some work. So we will essentially divide both sides, or you can think of it another way as you multiply by the reciprocal. So I want to cancel out 80 over 360, so I can multiply each side by 360 over 80, and that will cancel everything. So 360 over 80. So 360 times 20 over 80 times 9 pi equals the circumference of the circle. And then I can start doing some reducing. The 360 over 80, I can divide each side by 10. I have 72 on the denominator, 9 times 8. 36 times 20 is a little tricky. You can do 36 times 2 is 72. So this ends up being 720. So 720 divided by 72 is 10. So this is 10 pi equals the circumference. And then it said find the radius. Well, hey, we know the radius, circumference equals 2 pi times the radius. The circumference was 10 pi, so 2 pi r. So if we divide both sides by 2 pi, we find the radius is 5. And again, what we think we can do is try that again in the original problem. So the original problem says, okay, so if the radius is 5, let's just backtrack. What's the circumference? 2 pi times r. So 2 pi times 5 is 10 pi for the circumference. And then we say, okay, 80 degrees. So 80 out of 360 times 10 pi, do we get 20 over 9 pi? So if we go through and actually go through and do this and simplify, 80 over 36, 40 over 18, 20 over 9. I know I'm doing this fast, but it does check out, so it's always good to do. So that's how we solve this using the equation method. Let's do it one more time with the proportion method. So in the proportion method, still we want to find the radius. What do we know? We know the arc length and the angle. So those two are connected. We can say that 20 over 9 pi, that's the arc length, is to 80 degrees. And one thing that's often good in these problems is to find the circumference. So what is the full circumference then? If this is the arc length to 80 degrees, the full circumference is to 360. So we're going to do this. So we'll cross multiply. So 80 times x is 80x. 20 over 9 times 360 is 20. So that equals 20 over 9 times 360 pi. And again, this is mathematically easier with a calculator, but we'll do some simplification. So we can divide by, so 80x. So 20 times 360. 360 times 2 is 720. So times 20 would be 7,200, 9 pi. And so then 80x. 9 times 8 is 72. So 72 divided by 9 is 8. So this will be 800 pi. And then if we solve for x, we're dividing by 80 on each side. So we get x equals 10 pi, the same circumference we got before. And then if we have the circumference, find the radius. Once again, 10 pi is the circumference, equals 2 pi r. So r then equals 5 meters. We get the same answer. So the trickiest part here, which I'm rushing through a little bit, is how to do this without a calculator. With a calculator, obviously you could do this a little bit easier, and maybe we need to do more practice with the non-calculator skills. But the general principle here, you can use a proportion, you can use an equation, either method, but that will help you to get the radius of the circle in this way. So until next time, I am Derek Genova. Have a delightful day.